Good morning everybody. Thank you very much for attending and welcome along to this presentation, BIM for Product Manufacturers. Today we're going to be talking about specifically for people who make products, who manufacture products that are going to be used somewhere in construction. And we're going to broaden this and just talk about buildings, and we'll mention civil as well. So if it's a construction project and you're building a product, that's who this webinar is really aimed for. My name is Paul Monkford, Application Engineer at Greytech UK. And let me just begin by telling you a little bit about Greytech. So Greytech are the company that make Advanced Steel. That's the mother company. Advanced Steel has now been bought by Autodesk. So Greytech, the makers of Advanced Steel, have a worldwide presence. We have offices throughout Europe. Greytech, the reseller, the Autodesk reseller based in the UK, we have offices in Southampton, Milton Keynes, Nottingham, Bradford and Durham. So hopefully we're always nearby you somewhere. We're a platinum reseller. That means we sell a lot of licenses of Autodesk software. And we're one of the few platinum resellers to have offices also in the States. So we have a company in the States called TotalCAD and one in Canada. So we really are becoming to be a worldwide presence. Okay. So the topics for today, we're going to be talking about BIM. How can BIM affect my sales channel? This is what we all really want to know. Where's the incentive? Why would we get involved with BIM as a product? We talk about what is BIM, so I'll then take a step back and say, what is BIM? Why should you be interested? We'll talk about how we can take part. So what do we need to do to take part? What do we need to know? What tools, what technology do we need to have? And we'll talk about how do we create BIM content. So creating content natively, but also creating content if we are a user of mechanical CAD already. How do we repurpose our content? And we'll also talk about how do we share BIM content. So how do we get our content out there? How do we get our content out there to the people who are interested in using it? And finally we'll end up with a Q&A. So we should be here for about 40-45 minutes, something like that. So thank you very much for your time. So let's jump in with how can BIM affect my sales channel. So again, this is what we're really interested in. There's no incentive to get involved with BIM unless we think it's going to aid in the productivity of our company, aid in profit somewhere. So we've identified here 4 different areas in which we feel that BIM can help you as product manufacturers. So the first one is getting specified early. Now this isn't new. We've always wanted to get specified. And we've always wanted to get specified early on in the project. So there are very traditional ways of doing that through various different product searches and product catalogues that we've always used, so that when architects or interior designers or QSs are out looking for something to specify, they've got somewhere to go and they'll find us, and that's what we really want. But BIM is giving us a new opportunity in terms of content. So by putting BIM ready content out there, so a model, a 3D data source of our design, putting it out there early where people can find it, just means that they're likely to include that in their BIM, in their building information model. And one of the things about BIM is we can use BIM to produce schedules. So when we start scheduling out, start quantifying the project and doing the project takeoffs, if our stuff, our products are coming out on those schedules, then we get specified. Now that's not a promise that we will get the job, but at least when the main contractor gets the lists, he'll come to us for a quote. So we're kind of hoping that gives us a lead, and it's up to us then to turn that into a project. So one benefit is getting out there early, being proactive, putting our models out there. The next one would suit companies that perhaps don't provide a product as such, so you don't have something sitting out there on the shelf waiting to be sold. Instead you provide a service. So you might provide a service where you're going to design something bespoke for this building. So is BIM suitable for you, and how can you get involved? Well, really it's about the exchange of design data. So we're on a project, we've been given the specification to work to by an architect or an engineer, and we're now kind of come up with a design that we would like to be used in this building. So we need to be able to share our data. So maybe we're using a mechanical CAD system. In this case I've shown a screenshot here of Inventor. And we want to include our stuff. We want to be able to produce a model that can be consumed in the BIM. So this is another stage where we could get involved in BIM and get involved in the process by essentially doing a data drop of our design at any given point. I think we would probably still deliver drawings with this, because drawings are still our contract documents currently. but we're producing some data-rich 3D model that can be shared, that can be used for coordination, that can be used for clash detection, that can be used downstream to, again, start scheduling out information. So that's one other touch point where we can get involved in BIM. The next one is for those people who sit somewhere in between. So maybe you do have a product, but maybe you offer some bespoking. So maybe you offer a design but in a couple of different colors, or maybe there's a couple of different configurations that you can offer your customer. So this, I've got a screenshot here up of a solution called Autodesk Configurator 360, and what this allows us to do is take an inventor model that we've built as a configurator. So maybe we'd use some iParts and iAssemblies, maybe we'd use some iLogic, and all that stuff can be bundled up, wrapped up, pushed up into the cloud to Autodesk Configurator 360, and this can be embedded in your own website. It can even be your own branding, so you don't have to see the Autodesk branding. But then your customer can come along, and I'll indicate with my mouse here, they have a little control they can click on. They can click on this control and they can use the configurator you've built in. So they can go through and pick and click and choose all the different options they could have. And then when they're done, they can either click on a button where they can go to a quote from you. So they can just email you directly and you get a list saying, with this configuration, how much would it cost? Or they can download a file, and you get to choose which file formats are available. So in this case I've indicated Revit family file and an IFC file, which we'll talk about IFC later and what that is. But they can download a file if you would let them. You could also give this to your sales team as a tool, so your sales team can walk the customer through the configurations, and then when they're done they can produce a quote. So this is really for more complex items where you couldn't build all that intelligence into one CAD file. You want to be able to offer your customer some choice. Okay, so there's 3 different touch points where you could get involved in BIM. The last one was actually a bit of a surprise to me until I started going out there and talking to customers. But this is in the final stages. So many customers are now saying that they would like to have the BIM and they would like to use that as the beginning of their facilities management service. So really what we're seeing here is perhaps us moving away from an O&M, which is fantastic because nobody likes producing operations and maintenance manuals. We quite often leave it to the last minute and we print off a whole ton of drawings and we box them up and put them in a big van, and we know they all go down into the basement, nobody ever uses them. So by having the BIM, by having the building information model, the customer has a big old database of the 3D model they can then analyse and they can use at the beginning of their facilities management. Now for some companies, the maintenance contracts, the being in touch with the customer, so if the customer wants something repaired or replaced or maintained, is a really important part of their business. And in fact some companies would rather have that business than the original supply. They're willing to supply at cost if they can get the maintenance contract. So by the customer having access to your details directly, it means they can find you. It means they can come back to you and ask questions. And also we can provide a data link to that O&M. So perhaps the customer can link through with a hyperlink. They can come back to your website and they can look for a PDF, and the PDF could give them the cost date or the maintenance information or whatever it is you need them to have. So instead of us all having to go out and supply loads of stuff on paper or spend a lot of time compiling PDFs, we can keep that link live to the customer and keep that information directly to them. So I hope you'll see yourself in one of those 4 categories, or maybe a couple of them. So I want to just throw that in right at the beginning. So why is it useful? How can it affect my sales channel? But let's take a step back now and ask what exactly is BIM. Okay, so we've been doing something very similar to this in manufacturing for a long time. So we've been taking a 3D model and we've been using it to provide a database of information about our product. So we use it to compile a bill of materials, and the bill of materials is our data. So in construction, this idea has now been called building information modeling. And it's really exactly the same idea. It's taking a 3D model and using it as a database of information about our building project. And now one sort of key thing, one key difference between BIM and manufacturing, it's one of my favourite quotes. Let me just see if I can get this right. So manufacturing is designing one part and making 1,000,000 of them, whereas construction is designing one building comprised of 1,000,000 parts. So although we've got a very similar idea in that we're creating this 3D database of information, there are some fundamental differences to the way you would design and specify a building and the way you design and specify something in mechanical design. So let's just move on to this next slide. Okay, so why BIM? So how's that come about? Well, the incentive for this really kicked off in a difference between productivity between manufacturing and construction. So what this graph is showing us here is that, excuse me, in manufacturing, the efficiency of manufacturing has got more and more efficient over the years, and it's because customers have had a market where they can come to the market and they can say, listen, if you don't give me this product a bit cheaper, I'm going to go to your customer. So there's been this, I'm going to go to your competitor. So there's this real incentive in manufacturing to become lean, to get into this black belt and Six Sigma and all this kind of stuff, where we can try and produce the same product for less money in order to retain our profit margin. And so there's been a huge drive since the Second World War in manufacturing to try and become more efficient, try and become leaner. Whereas in construction, we can see things have gone the other way. We're costing more, we're charging the customer more. And unfortunately, we've set the bar so low in construction that construction has become synonymous with overrunning on project time, with costing more than you thought it would in the beginning, and that's just what our customers have been trained to believe now. It's a very unfortunate situation. So if construction is becoming less productive, it's costing the customer more, what do we do about that? Well, the biggest customer in the UK is the British government, and they were looking at construction, their own construction projects they run. They were recognising that construction projects costs were going up, and they asked the question, what can we do about that? And they put together this report with a company called McGraw-Hill. And one of the key findings, or the key finding for the purpose of this presentation we're going to talk about, was the use of BIM. So this government report identified there was a 20% reduction in waste due to the use of BIM. Now 20% is huge. And I just want to clarify, this isn't a reduction in waste as in bin bags full of rubbish on site. This is waste as in a waste of time. So it's a 20% increase in productivity, if you like, a reduction in wasted effort. So the wasted effort came from things like decision making. So with BIM, with working in 3D, you kind of have to make those decisions early. You can't fudge things like you do in 2D and think, well, I'll work it out later when I'm presented with the issue. You've really got to make those decisions, and we all know that in business, pulling decisions forward, making decisions, usually makes sense. Even if we think about it later and think, well, perhaps that was the wrong decision, making a decision is usually better than sitting waiting. Because the longer you wait, the more expensive your options get, and so you have fewer options because options start to become too expensive or aren't going to be done in the time. So waiting is never a good strategy. So BIM forces us to make decisions earlier, but it gives us better information to make those decisions with. So really the 20% reduction is a 20% reduction in rework, you could think, in stuff getting to site and it not working or it not fitting or it not being correct to the specification. And so we get to site and we have to take it down and do it again. And we all want to avoid that. So the government was so excited about this, they put it into their government construction strategy. So this is their mandate for 2025. This is where the construction industry is going, or the government would like to take the construction industry. So they would like to lower costs by 33%. They would like a faster delivery by 50%. They would like to lower emissions by 50% and improve in exports by 50%. And we could think of exports as in exporting our knowledge and expertise, not just not just exporting construction-based materials, but exporting our business. So really all of these can be effective with BIM. We can reduce waste and lower costs. We can have faster delivery because we can make decisions quicker based on better information. Lowering emissions is really about being able to do early stage analysis of our BIM, of our building information model, so that we can look at things like sun studies and we can work out the heating, ventilation, air conditioning load. And we should have a good accuracy, so when we actually produce the building, we should better compare that with the original results and say, does this actually perform the way it was designed? And that's something we're really interested in at the moment, because we're interested in the TOTEX, the total expenditure, not just the capital expenditure of how much we're spending on this building, and not just the running cost of the building, but the total cost, the TOTEX. So these goals might be lofty. We may or may not agree they're achievable, but you have to have goals, right, to kind of encourage everybody and set it all going. And what's key here is that the government haven't put this in legislation. They haven't said you've all got to do BIM and just giving off some bureaucracy that means we all pay money to comply but don't actually change our behaviour. What they've said is, as the biggest customer in the UK, we're going to say that we want BIM, and we know that's going to filter down to other industries and to other contractors. So the tier 1 contractors will get involved, and then maybe the tier 1 contractors will have other projects, and so they'll implement BIM on their other projects too. And the tier 1 contractors will employ contractors who can support them in BIM, and those contractors will employ suppliers and manufacturers who can support them in BIM. So I think it's a nice way of going about it. It's not too heavy-handed. It's leading the way rather than just telling people what to do. So this is all rolled up in the government construction strategy. So this is a document that you can read, and a couple of key points I want to highlight here. So the Cabinet Office will coordinate the government's drive to the development of standards, enabling all members of the supply chain to work collaboratively through BIM. Okay, so it's right in there in their documents saying they want BIM. And the government will require a fully collaborative 3D BIM. So this is a 3D building information model with all project and asset information, documentation and data being electronic. So no more paper. This is, you may still submit drawings, but they would be electronic drawings in maybe a PDF format, but not paper. And when we say all project and asset information, the 3D BIM, the building information model, can also be compiled against your project schedule, so you can see the way your BIM operates over time. We'll talk a bit more about that later. Okay, so this is where the government are, not where they're going, this is where they are, as a minimum by 2016. Okay, so if I just put this up here, the date was actually April the 4th, 2016. So if you're working on government projects that are starting after April the 4th, 2016, you will be required to produce a BIM deliverable. Okay, it's done now, we're doing it, we're getting on with it. Anyway, so if you'd like to find out more, you can visit, I've just slightly obscured that now, level2bim.org or bimtaskgroup.org. Level2bim.org is the government site, so that's where they'll put their latest updates. The BIM Task Group is a committee made up of individuals from government and from industry, specialists in many different subjects who've come together to try and work out how the delivery of this should work, so the standards and all that kind of thing. Okay, so these are two websites which you'd like to, which I encourage you to go and take a look at, maybe bookmark. You can either write them down, you can take a screenshot, or if you miss them, email me and I'll send you a couple of links. Okay, now this graph. You see this graph in every BIM presentation. I think it's mandatory, but I have to show you it. So there we go. So what this is, it's showing the adoption of BIM over time. So on the left-hand side here, at the lower end of the BIM wedge, we've got level 0 BIM. So this is basically, we're not using BIM. This is where we're using CAD. Now, CAD itself has had a huge effect on the construction industry. It's really changed the way we've worked, principally because electronic drawings, CAD drawings, 2D CAD drawings, you can email. And that's changed how we work, because we can work with people who are further apart than we used to work with, and we can swap information quicker. So the speed at which we can share information has really changed the way we work. I would say, though, it hasn't necessarily improved the quality. I think you'll all be familiar with working through a project where you're changing things so quickly that things change before you even finish the last set of changes, and you feel like you're in this endless cycle of just changing and reissuing. So there's some really good points about CAD and some less convenient ones. And you could think of CAD as being slight sort of chaos when we're using CAD. There aren't that many standards. People aren't really aware of what the standards are, so each company is kind of doing things in their own way. So although we do have electronic data, it makes it quite difficult to use it for the purposes of comparing each individual subcontractor's designs and making sure everything's going to work. So it's useful, but can be frustrating at the same time. Level 1 is kind of pre-BIM, if you like. This is starting to use some 3D. So 3D has been in construction for a long time, but 3D has really been used for the purposes of visualization. So early on in the project, when the architect is trying to win the project, they're producing 3D to produce really nice renderings and try and sell them on to the customer. 3D in terms of design has been around for some time, but it's been 3D as in terms of just designing the shape in 3D. So there are some benefits. We get a better idea of what we're designing, and we can be clearer that it's all going to work and it's all going to fit. But we're still dealing with basically CAD data, lines, arcs, circles, boxes, spheres, prismatic shapes. But they don't have any intelligence. They don't know what they are. So until you actually make a note on a drawing and say this is a wall, or this is a door, this is a window, it can be difficult to work out which bits are which. And we don't have any intelligence. So we're not being aided so much in our design as having some design automation, I guess. So level 2 BIM is where we are now. This is what the government want from us right now, level 2 BIM. So this means we're all working in BIM. So we're not just doing 3D CAD, we are doing 3D CAD with intelligence. So now when we're building objects, if we're building a door, it knows it's a door object. If we're building a door, it knows it's hosted in a wall object. There's some intelligence, there's some context to the design. When we schedule the doors out, the door is not just going to tell us, hey, I'm a door and I exist. It's going to tell us it's an FD60 door, it's going to tell us what its acoustic rating is. It's going to give us all the information we need to be able to schedule out a complete set of doors for our model. And so we can look at that in terms of performance with our customer, or we can look at it in terms of procurement. Now, one thing about level 2 BIM is that we're still operating in a distributed model. So the structural engineer will have a model, the structural fabricator may have their own model, the MEP engineer will have a model, the architect will have a model, and at different points in a project they're going to bring these models together and compare them. So we have some automation, we can do things like clash detection, but really it's a process of working individually and then relating your work back to each other to see that it fits. So the big difference between level 2 BIM and level 3 BIM, well, where we would like to go is that we'd like to have everybody working on a server and working remotely. So there is one BIM, there is one model that everybody dips into and does their work, rather than working separately and then putting their models together at different points in the process. Now in terms of technology, this is actually possible. We're kind of there already. We can just about do this. But contractually, can you imagine? You know, we can just go in and change whatever we like. I could go in there and just move a column out of the way because it doesn't fit my door where I want it to be. You know, I think contractually there are quite a few legal issues around who has access to what and when and how do we audit it and all that kind of stuff that still need to be worked through. So I think it's going to be a few years before we're ready to see level 3 BIM on multiple projects. I think really the aspiration is to work more like in manufacturing. If you imagine aerospace where you build a new jet and every single part has been modelled in CAD and compared and clashed and tested to the point that the actual aeroplane itself isn't tested. They put the thing together and they fly it straight out of the hangar and they just go for it. They don't need to test that plane because they're so confident in what they've done. But the difference here is in terms of how the contracts work. So in aerospace you've probably got one design engineering company that's running the whole project, whereas in construction we have this slightly distributed system where the client hires an architect, a contractor and a QS or a project manager separately, and so we can find ourselves at odds with each other. And I think that's really going to present more of a problem than the technology here. Anyway, down the bottom, just to point out some of these things that are going on here. So towards the left hand end we've got BS 1192 2007 as the standard. That was the construction industry standard for the exchange of data when we were dealing with mainly 2D CAD. That's really what that tells us about. As we can see, the cross between level 1 and level 2, this turns into something called BS 1192. BS 1192 hasn't been released yet. It's currently a PAS 1192. We'll talk about that a bit more later. But essentially it's been rewritten for BIM. So this is going to be our main compliance document for the exchange of CAD data, or exchange of BIM data rather. Okay, so how can we take part in BIM? So hopefully you've got a good understanding of what BIM is now and why it's around. How do we take part? Okay, so I just mentioned it then, PAS 1192. PAS stands for Publicly Accessible Statement. So what that means is it's not actually become a British standard yet, hasn't been ratified as a British standard, but it's currently in the process of being written and it's publicly accessible. Right? So this is now your opportunity to get hold of a copy and you can add your own feedback to that if you wish, and it's a good time to get hold of it because PAS is a lot cheaper than BS is. And I should also point out that PAS 1192 is it's not the complete standard, so it does point you as a reference to other standards. So there are plenty of standards that are there to document each area of BIM and the exchange process. So BS 1192 was mainly 2D and 3D CAD. PAS 1192 will be BIM. Okay, now I'm going to go through a whole bunch of different documents and phrases and things you should know about BIM, and this is really about having the language of BIM, so that when people talk to us about BIM, they phone us about it and want to know what's going on, or they want to come to us for a tender, that we understand and we can use the right language. So what else have we got here? IFC, Industry Foundation Classes. So IFC is a neutral file format for construction. Okay, so in manufacturing we'd have STEP, we'd have IGES. Those are the kind of neutral file formats we use. In construction it'd be IFC. IFC is a little bit like a STEP file, but it maintains its data. Okay, so it's not just the 3D CAD model, it also has the data that came with it. Okay, now interestingly, IFC is not an independent body like STEP. So STEP is controlled by one of the ISO standards committees. JT is controlled also by a standards committee, I'm pretty sure. IFC is controlled by a company called Smart Alliance, I think they're called. And it was originally set up by Autodesk, but it was sold off as an independent company. What this means is that their libraries are free, not free, but you can use their libraries if you're a CAD vendor. But each CAD vendor is free to use those libraries any way they like. And the problem there is that each CAD vendor has a slightly different take on IFC. So it's not like you can export an IFC out of one CAD package and come straight into another, and it's all going to be exactly correct, unfortunately. So IFC may well become the deliverable, and you may be asked for IFC, but it's worth testing the IFC that is produced by your CAD package with your customer, and just make sure the data is coming across that they wish to have, okay? Because it's not always the same, it's not always standard. So after IFC we have COBE, Construction Operations Building Information Exchange. Okay, so COBE is another thing you'll need to remember, need to be able to talk about with confidence. COBE could really be thought of as the data without the model. So we've talked about the fact that the customer at the end may well want this big data rich 3D model with all this information in it, but some customers don't have the ability to access that 3D model and don't wish to. They just want the data. They want the data out of the completed model so that they can, excuse me, so that they can, excuse me, so that they can fill their database with information. So COBE is the data export, and in this case I've shown you an Excel spreadsheet, but it could easily be go straight out to a Microsoft Access database or something like that. So if you get asked for COBE data, I hope you'll now have an idea of what COBE data is. EIRs, Employees Information Requirements. So this is the form which the customer would fill out so they can issue it out to whichever parties are working on the project. So it'd probably be the main contractor, the QS or project manager, any sort of consultant engineers. This is where the employer would specify that they would like a BIM as a deliverable. Okay, so you may not see this, unless you're a tier 1 contractor, you probably wouldn't see this form. But I can tell you that you will see some of the information in it that will make its way down to you. So if you can find this Employees Information Requirements form, it might be worth you having a look at it, particularly if you're in estimating and sales. These are the kind of bits of information which you'll be asked for, which will come down to you, and it's probably worth you sort of knowing what's going on with that and understanding it. The customer may specify BIM, but they might not specify exactly how we're going to do it. They'll just specify the deliverable. So they might say we'd like an IFC model with a COBE database, or they might say we don't care how you do BIM, but we want the native files when you're finished, whichever BIM product you're using to generate them. Okay, next one. Construction Project Information Committee, or CPICS, Pre-Qualification Questionnaire. Again, this is one that you may or may not see directly, but you probably will find that you'll get questions coming from these forms which are just being copied and pasted out and put into a pre-qualification questionnaire for you. So again, it might be worth you looking for these forms, downloading them, taking a look at them, thinking of your answers, and then just put them in a document so that your sales or estimating team can just copy and paste rather than having to think about it every time. It's useful if you can to answer in the positive. These things are scored, so that will help you get on the tender list if you can answer positively. But obviously, be honest. Don't say yes to anything you can't do. But try and be positive even if you can't do it. Okay, so that's another one. You might not see these directly, but you may find you get questions from these, so it's worth getting hold of them. Next thing is BIM statement. So this is simply an executive summary of your BIM policy, which you could put on your company webpage. So this is usually written by one of your directors, and it would simply say, let me just give you a couple of ideas of what might be in it. So you could say why you're committed to BIM, why you think it's a good idea, why you're willing to invest in it, a brief idea of what you're capable of, in terms of BIM and where more information can be found. So if you want to specify exactly which software you're using, or you want to highlight a project where you've already successfully implemented BIM, you could write a white paper, you could write a technical document, and you could just link to that in your executive summary. But your executive summary is something you can do straight away. So if you're happy to get involved in BIM projects, then put that summary up on your web page and just let people know. Let people know when they search the name of your company plus BIM and they find this, they find your BIM policy, that they'll have a good idea that you're willing to get involved in BIM. Another piece of information that you will come across, building BIM execution plan, or BEP. The BIM execution plan, so once you've got yourself onto a project where BIM is being the deliverable, the first thing you'll be presented with is a BIM execution plan. Now this is the more detailed document. The customer has requested that we do the project in BIM. This is the document that tells you about the deliverables. Okay, so this is the document that would tell you the file formats you've got to use, the data they're expecting to be captured in those files. It'll also tell you things like the coordinate system for the project. Okay, so if you're working to a common origin for the whole of the construction project, it'll tell you how you comply with that. Okay, so if you are tendering for a BIM project, I recommend you ask if there's a BIM execution plan straight away. This will tell you whether you can comply with BIM just by providing a specific file format. So it's no extra work, or it will tell you whether you're going to have to put some extra work in to comply with this BIM statement. It's worth thinking about that and where that cost is going to come from, whether you can charge extra for that service or whether you're going to have to accept less profit. Okay, so even if you're tendering, ask if there's a BIM execution plan and take a look at it. If you're actually on a project, you've won the project, you're working on it, if you're the CAD manager or the BIM manager for that project, ask for this document straight away and do some testing. Do some exports from your mechanical software, get it exported out there, get it over to the customer, and just make sure that everything you're doing is correct, so that when you actually start sending live data, you know it's all going to work. So who can help you with this BIM execution plan? Well, we can help you here at Greytech. So if you read a BIM execution plan and you're not quite sure what it all means or how to comply with it, give us a call. We're happy to work through it with you and work on which software solutions are going to help you comply. But the other person is the BIM coordinator. So every BIM project will have a BIM coordinator. The BIM coordinator is often working with the general contractor these days, but it could be working with the architect. The customer may even have hired their own independent BIM coordinator. The BIM coordinator will be the person who has probably written the BIM execution plan. So they're your first point of call. Who is the BIM coordinator? He's the person I'm going to go to ask any questions. And he's the person who you go to if you wanted to do some test exports and just make sure everything's working. So the last one to talk about in this section, common data environment. So you've maybe come across these before. Common data environment is usually a web portal where you can upload your documentation, and it just puts all the documentation in one place. So instead of emailing 5 different people with your documents and then all those people having to save their own copies, and then we don't know if we've got the correct copy, we don't know if it's up to date and all that kind of stuff. We don't know who's had what and when. We can't prove that somebody's had a document. So if they say I never got it, you can't prove they've got it. Whereas web portals, we can upload all our stuff, everybody gets an alert to say there's new information, and we can track and see who's looked at it and who's downloaded it. So we know the information on the web portal is always up to date, it's always the current release of information, and we can even do things like electronic markup on some of these portals, and so that we can track the whole audit trail of drawings from when they're first issued to when they're approved and released. So Autodesk's common data environment is called Autodesk BIM 360 Docs. So as a supplier, you probably won't need to maintain one of these yourself, but you probably will be invited to join them. So the question for you will be, do I have everybody in my drawing office trained to better use whichever project portal we've been asked to get involved with? Or do I have one person in my office who does all this and they know all the systems and my drafters just give them the information? The nice thing about Autodesk BIM 360 Docs platform is it not only manages our drawings, but it also manages our 3D models. So when you bring up your 3D models into the portal, you get a nice viewer. It splits the model out from the drawings, so you can supersede drawings individually. And it's cross-platform independent, so you can use it from your tablet, you can use it from your smartphone. So I hope you'll see this a lot more in future. It's a nice tool. Okay, so let's move on and talk about BIM content. So the tools we have for creating BIM content, one of the main tools is Revit. So Revit is Autodesk's BIM platform. It's the software we use for BIM. It's currently the most successful one in the UK, so it's the one that most people will be using. It's become kind of synonymous. Revit isn't BIM software. Revit isn't BIM. BIM isn't Revit. But Revit is our tool for doing this, and I think it's got more than 50% market share. So we're doing really well with this product at the moment. If you're producing proactive content, remember right at the beginning we said if you're a product supplier, you've got your product up there on shelves, you want to be able to produce some content, put it out there so people can download it and put it in their BIM products. If you're doing that kind of work, you probably want to create a native Revit file. And the reason why you probably want a native Revit file is it's going to be a smaller, lighter file that's designed to be used in Revit. And we can include in one Revit file, a Revit asset is called a family. So we include in one Revit family a number of different family types. So you could offer one family that has in it maybe different color options or maybe has different sizes. So your customer can download one file and then they can choose from the different types available. So if you're being proactive and putting that content out there, it may be you either want to get hold of Revit and you want to do some Revit training to produce your content, or you want to commission somebody else to produce that content for you. That's certainly one approach. How about Inventor? So if you've got Inventor, you can repurpose your Inventor models for BIM. Now, I think this really suits those people who are going to be supplying they're not supplying a product, they're supplying a service. Okay, so if you're supplying a service, so you're going to design something bespoke for that building, Inventor is a much more useful tool for doing manufacturing design, but you can still participate, you can still provide that content in a Revit-based format, and we'll look at this later. I've got a little demo of how this works. So we can export some stuff out of Inventor and we can import it into Revit. Okay, so Inventor is a great tool for producing that BIM content for those people who are doing that sort of service. We also have something called Navisworks. So Navisworks is really a content aggregator for BIM. So Navisworks isn't something you use for designing models, it's something you use for bringing them together. So you could bring in content from Revit, from AutoCAD, from Inventor. You can bring in data from, I think, sort of 50 different file formats. So it will really accept almost anything. And what you do is you use it for compiling all the different models together to see whether they're all going to fit. And the really nice thing about Navisworks is also where we do our 4D BIM. We mentioned this slightly earlier. So apart from bringing in the 3D models, we can also bring a Gantt chart in of our production schedule, or our construction schedule. And we can pin the items, 3D model items, to the schedule. So as we animate the schedule and play through the schedule, we begin to see an animation of the building as it is going to be built in 4D and in time. So this is really helpful for doing things like temporary works. We can look at where temporary works are. We can look at things like loading. We can say where can we offload materials to, where's going to be a convenient point. So we can use it for project planning. And we can use it for planning things like the crane. You know, when can we get the crane in and when can we get the crane back out again? Make sure that we can get it out. And so it's a really good sort of content aggregation and planning tool, but you may be asked to supply Navisworks files as your deliverable. So what you do is you take your Inventor model, you open it up in Navisworks, you save it, and then you can then send that off to your customer who's written the BIM execution plan. Okay, so a couple of different tools we've got from Autodesk for doing the work here for BIM. We used to get these in something called the Building Design Suite, and we'd get all of these tools in. Now we've moved to collections. And unfortunately we don't get Revit and Inventor in the same collection. So if you're interested in a seat of, if you've already got the manufacturing collection, you're interested in a seat of Revit, that would need to be an additional thing you need to come to talk to the sales team about. Okay, so here's a couple of workflows. So if you're a product supplier, original equipment manufacturer, then you probably want to produce parametric Revit families, so families that can change in size with different types, and you probably want to work in Revit. Okay, so that's probably the best deliverable for you in that situation. If you're producing something that's entirely bespoke, so you don't have anything to begin with, you're just going to create something for that customer, then probably you want to work in Inventor, and you would either export out to Revit or Navisworks for the purposes of coordination. And the final workflow is if you have a catalogue of items which the customer can alter slightly, then probably your best bet is to work in Inventor, build that configurator, then upload it to Configurator 360 and allow then your customer to configure what they're after and download that Revit file for their project. So a few notes on preparation before we start. File formats. So this is really important. So we talked about Revit family files. That's an RFA. Okay, so if you're putting that content out there proactively, putting the content out there for the customer to download, it will be Revit family files that you're dealing with. If you're working on a project, then your deliverable could well be an IFC, a neutral file format, could be an NWD, a Navisworks file. This is when we open it in Navisworks, save it, and send it off for coordination. A format for you to be aware of is the ADSK file format. This is really an interchange format. So this is one of the formats we can export out of Inventor and import into Revit. But when we import into Revit, it's converted into Revit family. So eventually we have that Revit family available to be shared with people. So that's just a sort of temporary exchange file format. We also have DWG, which is AutoCAD, still being used. I won't deny it. We're still sharing DWG files with each other. And we've actually found when we're importing and exporting out of Revit, InfraWorks, Civil 3D, Inventor, quite often the DWG actually gives us the best results, with all colours and data preserved. So it's still a very useful interchange file format. And we also have SAP files. So SAP file, like STEP and IGES and JT, is a neutral file format that can be accepted by Revit, but it's a 3D model only. So if we just want to use the 3D model data, and we'll add the additional product data in later, SAP may be the exchange file format we'll use. So when you're creating BIM content, have in mind which file formats you're going to deliver in. We also need to think about release. So if an architectural firm's got involved with a project, quite often these projects can be a couple of years in planning and then a few more years in execution. So a construction project can well take 5 years to go from beginning to end. So if the project was started in Revit 2014, they're probably not going to change products halfway through the project. They'll keep that project in the same file format. Otherwise it becomes just too difficult. If you think about those aggregated models, everybody working on the project needs to be working on the same software, same release, in order to better bring together and compare them. So they're probably not going to change releases as they go through. And you may find that even though it's 2017, that people aren't using the latest version of the software. So if you're producing, again, if you're putting libraries of Revit family files out there, you might want to think about which version of Revit you use. If you supply them in a 2017 file format, Revit is not backwards compatible. And so customers who are still using Revit 2014 won't be able to open those files. So your best bet is probably to issue them out as Revit 2014 files, and then any customer who's using Revit can open those files. If you're producing your content as a bespoke as a service, and you're just providing content through the construction phase of the project, this should be in your BIM execution plan. They should tell you which version. So if they're saying we would like a deliverable of a Revit file so we can bring it into Revit and do clash detection and just make sure everything's coordinated, they should be telling you which version of Revit they're using. And if they don't, you need to ask and make sure it's you understand. Just as a side note, Autodesk support the previous 3 releases of any product, including the current release, so that's 4 releases. So currently Revit is being supported, we're on Revit 2017, that's the latest version of Revit. So we're also supporting 2016, 2015, 2014. So 2013 would be unsupported. So I would recommend you don't go any further back than that. 2014 is about as old as you want to go. So file format is important, release is important. Now here's an interesting one, category. So in manufacturing we don't really have a full categorization system for everything because it's just everything. We could manufacture anything we like. But in construction we do have that context. We know we're building a building, all right? So we know that we're going to have walls and floors and roofs and ceilings. So in construction we have a various different ways to categorize building components. Revit uses the OmniClass system. OmniClass is an American system of cataloguing stuff. In the UK we usually use Uniclass. Now you can put Uniclass into Revit, but that's a slightly different topic. For the purposes of this topic we're just thinking about category. So in which category would we like our product to end up in? So this is useful for when you're doing quantity takeoff. So if you want to do a quantity takeoff of all the columns, you'd want to make sure your product is in the columns category. If you want to do a quantity takeoff of all the doors, you'd want to make sure your product is in the doors category. We'll see when we do the demonstration towards the end of this presentation that we can use the classification system to find out which category our product should be in to make sure that when our product is quantified that we end up in the schedules and tables we want to be in. But again, it's a good question. So if it's not clear in the BIM execution plan which category your product should go in, then perhaps you should ask that question. Is there a specific category that you're expecting my product to end up in? I want to make sure that, that I choose that correctly. So category is a consideration, and then data is a consideration. So what data are we expecting to share with this model? Now, you may be asked to produce COBie data. There may be specific data in the BIM execution plan you've been asked to supply. You may want to also include some of your own data, so you may want to include your manufacturer's URL, so there's a link back to your website that people can click on to find out more about your company and the services that it offers. Maybe you want to include a URL back to your product data sheet, so if people want to find out how it's maintained, how it's serviced, they've got a product data sheet which is on your website they can visit, so you can control that and make sure it's always live and up to date. Okay, so what data you put in there? Again, if you're supplying library components, you could make sure you could anticipate and say I'm going to include all the COBie data in there. That could be a good move. Lots of customers would like to see that. It's very professional. But I have to say, as much as we talk about COBie, it's a requirement of BIM level 2. Not everybody's using it. So you could actually keep your library components pretty data light and just offer the service. Let people know you're willing to tailor it to suit their products, their projects, if they've got specific data requirements. If you're working on a project, again you're providing a service, once again you should be looking at the BIM execution plan. What data am I required to supply with this product? And I want to make sure that data is all correct. Okay. Here's another subject to talk about, level of detail. So in manufacturing, we want everything at a detail of 1:1. We're literally building a digital prototype of the thing we're going to manufacture. The more data we can put into that model, the closer it is to real life, the more useful it is to us. So we always think of our 3D model being an exact replication of what it's going to be in real life. In construction, we kind of don't have that luxury. Remember, we're building a building of 1 million parts. This is going to be a big model. There's no way we can include in every nut, bolt, fixing and every little tiny detail. So BIM software generally will model to a much lower level of detail than we do in manufacturing. So this is a good question to ask. How much detail do you need? And essentially you'll usually be given a guide of like, well, don't show me any feature that's less than 10 millimeters in size, or maybe 25 millimeters in size. But they'll give you a clue. In Revit we have an opportunity to build a number of different level of details into the same item. So we can build a 2D level of detail, we can have a very blocky conceptual level of detail, then a more defined level of detail, all within one file. When we're exporting out of Inventor, well, I'll show you how you can sort of thin it down a little bit, but essentially we just have one level of detail, so it's worth knowing what you're trying to hit. Now, interestingly, on the project, the rendered level of detail is probably the first level of detail an architect would want, okay, because they need to win a project, so they need assets they can put into their BIM. They're going to look really cool, so they can produce a nice rendering, yeah, so they can win the project. When they actually get on the project, if you've got this chair design on the right hand side here, it's really detailed. If you've got 500 of those in your BIM, that's taking up a lot of memory. So you might actually just go to that schematic level of detail, because really what do you need to know? You need to know how many chairs, that's it. You don't need to have a full 3D model. You might later on to move to the conceptual or defined level of detail in your models, but I thought it's just interesting to point out that it's not a question of getting more detailed over time. In fact, the more detailed work probably happens at the beginning, and it might even get less detailed as you go through the project because your information requirements change. Anyway, good question to ask. How much detail do you need to see in my model? Another guide could be file size. Rule of thumb, if your model can be about 1 megabyte on disk, you can be pretty confident that's a good size. And again, this is because you may be using that model a number of times within the BIM. So if you're designing something like a reception desk where you're probably going to have one of them, then and your reception desk export was a bit bigger than 1 megabyte, I wouldn't worry about it too much. But if you're producing something again like this chair, and you've produced a chair model that's more than a megabyte, that you probably don't want that. You probably need to do a little bit of extra work. Okay, so next topic is hosting. So once you've got your BIM content, what do you do with it? How do you get it out there? Well, there are a number of different ways you can share it. So in the bottom left of this file, slide, I have Autodesk Seek. So Autodesk Seek is a BIM content platform. You can upload your models. People can search it through, and they can try and find your data to use in their projects. We have a couple that are specifically UK based. So I've put up here BIM Store and MBS. MBS is run by Reba, so that's a sort of interesting link in there. So these are content distribution systems are really helpful. You're not charged as a user. So if I'm an architect and I go on one of these sites looking for a chair, I'm not charged. The product manufacturer, once their stuff hosted, is charged. And so part of the service that people like BIM Store and MBS offer is promoting your content, is getting it out there, helping you get it specified. And they can also give you reports of who's visited the site, who's looked for your stuff, who downloaded it. So you can approach those customers directly. So that's one way to go about it. The other way to go about it is to self-host. So you put the information on your own website. So it's a little bit cheaper to do, although you will still need a website, a server, and probably some sort of developer to help you put the information up there. But you have a little bit more control over who can use your content. So you could put it behind a firewall where people have to give you an email address before they can download the content, and maybe that should just allow you to sort of filter slightly who's actually using it. But again, it's leads for your sales team. It's your sales team able to say, we've had an inquiry, we've had some people download our content, let's give them a call and see if there's anything else we can do to help them with. Okay, so who's ready for a demo? Let's just flick over to this unit. So this is an air handling unit that I have in Inventor. So we're going to look at a couple of workflows for repurposing our content from Inventor out to Revit. So we're going to imagine this case that we've been contracted to design this air handling unit, and we've finished our model. We have our complete model in Inventor. So this is everything we need to know to manufacture this unit. If I just open up here my bill of materials. So my bill of materials is my database view inside Inventor. So in Inventor I have this BOM, and in my BOM I have a full listing of all my components. This would allow me then to be able to manufacture or procure all the components that I need to be able to create this item. Okay, so this is 100% detailed, it's as accurate as I can make it, it's as close to real life as I can make it. Now if I wanted to export this out, so the architect has asked me to provide a model of this that he can use inside Revit. So you can use this for some coordination work. No problem at all. I'm just going to come up here to my Environments tab, and in my environments I have my BIM Exchange tools. So I'll just click straight on there, and the first thing I can do in my BIM Exchange environment is I can check and see kind of how big my model is. So what's going to happen when I exchange this? So the tool I'm going to use up here is called Check Design. So I'll click there right to begin with, and Check Design brings me up a report. I'll just scoot this over from my other screen. So my report is saying this has a model complexity which is high, and I have 566 occurrences. That's 566 occurrences that the part files have been loaded, and I have nearly 20,000 faces, or 19,000 faces in there. Okay, so this is giving me an idea. This is a pretty complex model, and I could export this directly out exactly as it is, and it could just be then brought into Revit, and it could be used for coordination. But they probably wouldn't thank me for that, because they probably don't want that much detail, and they probably don't want a model of that size. So let's see what we can do to clean this up a little bit. So I'm just going to click on my Finish BIM Exchange icon, and before I even start, I'm going to use a shrink wrap level of detail just to thin this down. So if you're not aware of how Inventor works, down the bottom right hand side here, here's our occurrences. So we have 566 occurrences, 235 files. So we have 235 unique part files, and some of them being used more than once. That's why we have 566 occurrences. So if I drift my mouse over here to my feature tree, my browser tree, so here I have pattern, for example. So that pattern is producing a number of occurrences of the same part. Okay. So the first thing I could do is I could wrap this all up using a shrink wrap substitute into one part. Okay, so I just have one part that represents the entire item, and that would thin things down a bit. So let me show you how we do that. I'm going to come up here to level of detail, I'll right click here and I'll choose new substitute, and I'll choose new shrink wrap. Now the reason why shrink wrap is interesting, because shrink wrap has a couple of algorithms in there we can use to lighten up the load as we go. So I have a new component name, I have a file path, I'll just click on the default so that's OK. So what you should see straight away is Inventor is opening a part file, and inside our part file it's going to create a reference to the assembly, and it's going to derive in all my individual parts as bodies. So I can choose here, firstly to begin with, do I have a single composite feature? So that's just going to be surfaces. Or do I choose to maintain each part as a separate solid? So that's going to be still pretty sort of high weight. I could choose whether to have solid bodies but keeping seams between faces. So this is useful if you, for example, split a face so you can show a different colour on a different section of the face. You'd want to click this one if you want to preserve that. But I'm going to go right here and choose a single solid body merging out seams. So this is giving me a solid body rather than a surface, but it's the lightest weight option for my solid bodies option. Now, I have a couple of different options down here to simplify this using algorithms. So remove geometry by visibility. So what that's going to say is if I can't see it, should I remove it? And the percentage here is a percentage of the total size of the part of the assembly file. So if everything in assembly is 100%, so if I put that to 100%, everything would disappear. But I'm going to put this to about 15%. And what I'll do then is I'll need to click on preview to see how the changes have affected this assembly. So if I just scoot this around a little bit so we can kind of see what's going on with it. Okay, and then I'll click on preview. And it's going to run this algorithm and it's going to build us this derived part. So we derived in all assemblies. And you can see there how it's removed some of those components. Okay? So we can choose to simplify by removing components that are invisible. We can also remove components by size. So this one I'm going to set at about 5%. Now, this is an algorithm based on the total size of the assembly. So if this assembly was twice the size or contained twice as many components, the percentage here that I put in 5%, it may not be the same every time. So you will need to go through this process a couple of times, just choosing some ratios, hitting preview, and then seeing what you get in your preview and thinking, is that appropriate, is that okay? Has Inventor taken away some details that I actually wanted? Okay, so I think it has actually. I'm going to set this to 3 and run it again. I've just missed a bent pipe over there that I would like to keep in. So I'll do my preview again. I'll see what happens this time. Okay, that's a bit better. I'm going to keep that. Now the other thing I can do is I can turn on hole patching. This is currently set to all, but I'm going to put in here a range. Now when this says holes, it doesn't mean circular features. Okay, it could mean any pocket, any indent into the component. So I'm going to set this to a range of 350 millimeters. So 300 millimeters is the perimeter. Yeah, so that's the biggest perimeter. And then I'll hit preview in a moment, but just to begin with, I'll untick work geometry and sketches. I don't need to include those. I am going to tick this option here, remove all internal voids. Now, out of interest, if there's any of you out there that have to share models with your competitors, you perhaps don't want them to see everything that's going on inside your product. So quite aside from BIM, if you ever need to do collaboration work and you want to put a model out there, but you don't want to give away too much of your IP, create a shrink wrap and tick this, remove all internal voids. And it just means that it's going to fill everything as a solid. You don't get to see any of the internal components at all. So let me preview that once more. Okay, so again we get a preview up there of what it's got, what it hasn't got. It's patched some holes, it's filled internal voids where it can, it's removed some features. So I'm happy with that. I'm going to click OK. So what Inventor will do now is it'll take this part file we've created, contain this derived reference to our assembly, and it's going to put us back into the assembly. And in the assembly we should see that we have replaced all those 566 occurrences with just one occurrence of one file. And it's that file that we can then export out to Revit, and we should have something much simpler. So here we have our substitute component, and here we have our substitute level of detail. So maybe I'll just rename that export to BIM. And what's absolutely key to understand here is if I double click back on my master level of detail, it's going to load all those components back in again. So we'll see in a moment our full assembly with, there we go, our full assembly with all components, and then double click on export to BIM to swap all those components out with our reference to our derived part file. So what we can do here is we can continue to work on our design. We could continue to add stuff to our main assembly. We can add detail, we can add components, and when we're ready we trigger that export to BIM, we update the substitute component, and we're there again. So it's part of our workflow. It's not something we can only do when we're finished. We can actually set this up quite early on in the project and then just update that algorithm continuously as we go through the project just to make sure it's up to date before we export. Fantastic. So let's take a look now. We'll come back up to Environments tab. We'll go back to our BIM Exchange. We'll click on our Check Design and see what sort of result we've got. Okay, this is pretty good. So we've still got a highly complex model, but instead of 566 occurrences, we've just got one. Instead of those 19,000 faces, we've got 4,000. So that's pretty good. That's really going to help. So it's definitely worth doing a shrink wrap before you export anything out to Revit. But we can continue to do work on this to make it even smaller. So let me just show you some of the tools we've got there. So what I'm going to do is I'm going to open up this substitute file directly. So I'm going to right click and choose Open. Okay, so now we're working directly inside this part file. Okay, so this is our substitute part file. This is our derived reference. And if I right click here, I can choose Edit Derived Assembly. And you should see here we get the same options back up again that we had before. So again, this is another important point. Once we've run that algorithm to create our shrink wrap component, we don't have to run it again and create a new shrink wrap every time. We can edit the existing one. So if we didn't like those settings we chose, we can always go back, we can always edit it. It's like anything in Event, you can always go back and edit. You don't have to delete and start again. So let's just wait a second for this dialog to pop up. Here we go. It was just running an update there, so again it understood there's been some changes and it's updated the substitute. So you can see here we have the full reference loaded back in again. We've got all those details we saw before. If I click to my Options tab, here are those same settings we saw last time. Okay, so we can go back and change any of these settings from our derived assembly. We can choose a specific representation if there's one we want to peg this to, a visibility representation or positional rep. We can also choose specifically which components we would like to include or not include. So this is quite useful, just being able to eliminate components entirely. So our algorithm did this for us via an algorithm, but we can come in here and pick and choose and say we'd like to have a component shown or not shown. So this gives us a really fine level of detail on exactly what to include. And the other thing that's quite helpful in here is we can also take a look at some of these bodies, and we can replace a body with a bounding box. So if I keep clicking through till I get this green box, it's going to replace that body with a bounding box there that represents the extents of that component, rather than having to manually create bounding boxes later. So I'm going to leave this one, I think, for us to look at next time. And I think I'll switch some of these background ones to bounding boxes. And we'll see how that has, again, really simplified this model right down to produce something that's going to give an item that's the correct size, but we're not going to worry about it being exactly detailed like a manufacturing model is. Okay, so again, we've removed information, so that's going to be really helpful. Now, in part files, we have some specific tools for simplifying stuff for BIM. So if I direct you up here to our BIM tab, and on our BIM tab we have a couple of things. I'm going to talk through the simplified tools first. So the Remove Details tool. Now, Revit, as we discussed, needs a very, very simple 3D model. It's really kind of a placeholder for the data. The data is more important. It's a building information model. Okay, so it's not a manufacturing model. We're never going to take a Revit component and build it exactly. So traditionally, just the same way architects would usually draw to maybe a 1 to 5 is really the smallest or the most accurate level of detail they're going to draw to. Our Revit models are kind of detailed to about that level. So Revit doesn't have tools for doing complex features like fillets and chamfers, and it can't do lofts. So we can do some really complex surfaces invented that Revit just can't match, but it doesn't need it. That's not what it's designed for. So this tool here allows us to remove, and if I hover my mouse over here, you'll see it allows us to remove things like fillets and things like chamfers. So we just run that as an algorithm across our whole model. Now I tested this earlier, it took a little bit too long to run, so I'm not going to do the whole lot, but let me just find one and grab it for you. So I'll grab this fillet, and what I'll do is I'll say remove that fillet. And what happens is that Inventor just removes that face and it just trims it back. So we're just making something that's a little bit simplified. If we turn on all faces selectable, then really we can select any face and trim it back. So I could, again, I'll select these fillets, but maybe I could select a couple of chamfers in there as well, and then just say, yep, go for that. and we'll see again how these are trimmed back and replaced. Now again, Inventor will try and find these fillets and remove them for you as part of that algorithm. So if we update our main assembly, it should trickle all the way through. You know how Inventor works. If we remove those features and they're not available, it'll probably throw an error. So we just need to be a little bit careful at this point. We can also fill voids. So fill voids allows us to take any features which we haven't already cleaned up with our algorithm, and we could then fill those in as voids. I don't have a great candidate here because, let's just try that. See, wow, look at that. Let's see if that will give us that void. So if we didn't hit anything with our patch holes tool, the fill voids tool would allow us to come in there and try and patch in any additional voids which we didn't hit before. Okay, not going to let me do that one, but you see what I mean. You see what we're going to do there. So we could patch that in individually, and we can also define envelopes. So define envelopes allows us to create square bounding boxes or cylindrical bounding boxes. We pick a face. If I pick resize there, you should see it allows me to just drag out a shape. And if I make sure I pick a line, I could align with the bottom of the shape, align with the top of the shape, and then maybe just drag that out in terms of size a little bit. And you see again how it allows me to replace something that's quite complex with something that's a lot simpler. And again, this is all about producing something which has the correct detail in there, but it perhaps doesn't need to be as accurate as we would have it in real life. Now, we also have this tool here called Check Revit Features. So what this allows us to do is it allows us to say, could Revit have built this? And if we click Check Revit Features and it returns a result that says yes, Revit could have built this, then we'll be able to export it as a Revit file. Now if we hit Check Revit Features and it says no, this is too complex, you can never build this in Revit, it wouldn't let us create a Revit file for this item. Now I'm not going to go through that today because plainly it would take us a little while to clean this model up to export out to Revit. It's a good tool for things like parts, individual parts, but for bigger settings like this, I think we're probably going to use these more algorithmic tools where we can run through automatically. Anyway, so we clean this up a bit more. Let's move back to our Environments tab. So I'm back here in the assembly. I'm going to click again on my BIM Exchange tab. Let's take one more look at Check Design. So we've managed to again reduce the complexity, reduce the number of faces, and we've just made something a little bit simpler that we can then export out to Revit. Okay, so the longer you spend on this, the more you can get it reduced down, and the simpler you can make it, and the happier the recipient will be. So let me just click on Export Building Components, and let me just drag across this from over the screen. Okay, so this one choose the Revit family format, the file format. I'm not going to choose Revit family today because, as I explained, that would take a little bit more setting up. I'm going to do an ADSK file. We can choose our origin. Component type classification, again, this is our category. So if I click here, this is where we find our product. So if I typed in air and did a search, I could look down here and try and find our air handling unit. Now what's important about this, you can see down here which Omniclass node refers to which Revit category. So if you've been given a category by your customer and say, I want this to appear in the doors category, any of these nodes are absolutely fine. Okay, so if you've got a specifically airtight door, you can pick doors, it's all good. This information will be helpful, it's in the right category, we're fine. If you're not sure, go up to a higher level node, okay, because you're still going to be collected, when they do a table of all the doors, you're still going to be collected in that table, and you're still in the right category. Okay, so just if you're ever worried, kind of go up and pick a higher category if you can't find your one specifically. And again, if you're worried about it, talk to the BIM coordinator and see if there's a specific Omniclass number that they could help you find. So I'm going to go down here and I'm going to be looking for mechanical equipment. I think I'm going to put this in. So mechanical, do a little search. Let's go for HVAC distribution devices, mechanical equipment. Yeah, that would be great. So I'll pick that. So that's my category. And finally, model properties. So I'm going to pick on the filter here, and you can see that we can include model properties from our Inventor model. So these are going to be the properties that we've got in the assembly, and we can choose specifically which properties we'd like to extract. And we can also choose whether we want to extract any custom properties. So if I just tick model properties here, you can see all the model properties that would usually come out of there. Okay, so if there's specific information like our Kobe data that we've been asked to produce, we'll need to put that information into the assembly as custom properties, and then we can make sure they're extracted when we actually do our exchange file. Okay, so when we're all done, I'll pick OK. And this allows us to export our ADSK file, our interchange file format. So I'm going to click Save. So this is now publishing the 3D model out. It'll give us a report when it's finished and tell us how it got on. And what we'll do finally is we'll open up that ADSK file in Revit, and we'll just see how that got on, that worked for us. So we're nearly there. So I'll view the translation report. So we have the translation report comes up here telling us how it's translated. It says no front view, back view because there was no 2D data in my model. It's an Inventor model, so it's all 3D data. But it gives us a bunch of information we can use to sort of see what information was extracted and how successful it was. So if I now switch us over, I'm going to grab Revit from my other screen. Just bear with me a second. Here we go. So I'm grabbing Revit here. What I'm going to do is I'm going to choose Open, and I'm going to browse out and find my my exchange file there. Let's go back to Inventor and double check and see what I actually exported out as in the end. Straight into the building products. Okay, here we go. There we go, there it is. So I'm now going to open this up, and what Revit will do is it will open up a new Revit family, and the Revit family will be based on the category that we chose. So that tells Revit which family template to use, and then it's exporting that data in, importing that data into Revit from Inventor. So here we go, that's imported now. So if I come up here to my categories browser, I can see my category is mechanical equipment, and as I scoot down here we should see that's the Omniclass number we picked, HVAC distribution devices. If I just turn on my preview visibility, so we get a preview here of what this would look like. So our realistic colours. So that's how this is going to look in the model. And the last thing I'll do there is just create a new Revit project using the architectural template. I'll just jump back to my ADSK file. I'll choose Load into Project. And then once we're in the project, we can then start placing copies of this component. So we would then come across to our schedules and quantities, create a new schedule of quantities, choose mechanical equipment, and choose OK, and then we just bring across a couple of different of these items. Choose OK, and you see it's scheduled out the number of items we just placed into that project. So that's the workflow right way through from start to finish. So I'm going to jump back to the PowerPoint now. So I'm happy to do a Q&A. Let me just take a look. Has anybody raised any questions while we're talking? So no questions have come through while I'm talking. So if you've got any questions, again, put them in the questions box or put them in the chat box, and I'll take a look at those. But I have prepared some questions because sometimes it takes a little while for them to come through. So, first question, do I need Revit to create BIM content? Who knows the answer to that one? So I hope you'll all be saying, no, I don't need Revit, but I might need it for checking file translation. Okay, so if you've got Inventor and you're intending to to participate in a BIM project, so I hope I've shown you there how you can extract data out of Inventor and include it in BIM. But you might want to be able to open up that ADSK file or that Revit file in Revit just to see what you've got and check it. So Revit LT might be a good choice for you. You can just open it up. If you're doing heating, ventilation, air conditioning systems, you can actually produce Inventor components that have all the correct piping in to be able to include them in your MEP model. But what I would say about that is you do need full Revit to be able to check those. Okay, so you're talking about a slightly different product there. Can I buy Inventor and Revit as a package? You can't currently buy Revit and Inventor as a package. If you've got a product design suite or a construction design suite, I think it was called, keep it because Autodesk are no longer doing those suites. So keep your maintenance contract up to date so you get the latest versions of the packages. We're now selling products in collections. So we have a manufacturing collection, an architectural collection and a movies collection. So Inventor and Revit are not in the same collection anymore. So if you've bought the manufacturing collection, you would need to get Revit as a separate item. Okay, so in different collections. Where can I find out more about BIM for MFG? Here's the main page here on our GreyTech site. So you can click on this link, or you can, if you write it down, or go and find it now, or Google it, or just email me and I'll send it to you a link. So you can find out more information there. Can I have a copy of this presentation? Yep, sure, no problem. If you want to just email me, then you can. I'll send you a PDF version of it. So if you want to go through some of those notes again and what BIM is and how do we comply, then you should see them there. And if you want to help other people at your company understand what BIM is, then by all means let us know and maybe we can come and help you out. Okay, so I've got a few more questions come through, so let's take a look. So there's a great integration between Inventor and Revit, making a very good choice for any manufacturer associated with BIM. Quite right, Mike, thank you very much for that. Is there BIM training suite for Inventor and Revit? So training suite, I'm not sure what you mean. Is there training? Yes, we can do training for building product manufacturers. We can come and do a day on how to export stuff out of Inventor and bring it to Revit successfully. Is there a suite? No, I think we've covered that they're no longer sold in suites, they're sold in collections. Is there a role for Vault in controlling the data associated with your internal designs and BIM, e.g. PAS 1192? So that's interesting. So Vault is a data management system for Inventor, but Vault can be used for data management for anything really. We can use it for Civil 3D, we can use it for AutoCAD, we can use it for Revit. So when we talk about the common data environment, the common data environment will be a shared environment in which you publish your data to, so it can be collaborated upon and checked. But internally within your company, you'll have your ISO 9001, you'll have your standards for how the data gets moved around. So Vault can be a great product for doing your BIM content because it can contain both your Revit files and your Inventor files. So you can have your own internal audit trail of when you exported stuff out from Inventor and created that BIM content, and before you export up to the common data environment, you can make sure that everything is tracked and managed. So they work really nicely together. I have used Inventor for a long time, but never Revit. So that's not a question, but a comment. Thanks, Thomas. If you've used the Inventor, you can use Revit. The modelling in Revit is actually pretty simple and straightforward because it doesn't do as much as Inventor. So you'll probably find Revit a little bit frustrating in terms of what you can model. You have to go right back to square one and just do things really simply. But Revit's really about the data. It's making sure your categories are correct. It's making sure that parametrically that everything updates when it should. So I wouldn't be afraid of using Revit if you use Inventor. Question here, do you think marketing is an essential part of BIM for manufacturers? Absolutely, because if people don't know that you're BIM compliant, then you've lost your edge. Okay, so this is, we're right in the middle of BIM here, and BIM is now becoming the everyday tool of choice for many main contractors, because that 20%, don't forget, that 20% saving for the customer comes from the contractor charging the customer less because they've made the 20% saving. Okay, so as a contractor, the benefit is to you. You can save like 20%, or you can save. You can make your products more efficient, more effective by using BIM. So you want to use it. Of course you want to use it. So you need people that can help you. So you need product manufacturers and suppliers who can help you in your BIM process. So yeah, absolutely market it. Get it out there. Tell people you're willing to get involved. You think it's interesting. You think it's exciting. You're prepared to invest in the technology, and you can have part of that 20%. You shouldn't necessarily have to charge people extra for this. It should be something which you can use to reduce costs and therefore pass that saving on to the customer, rather than having to charge extra as additional service. Can I look at the presentation again as I missed some of the slides? It's from Alan. By all means, Alan. You can email me directly. My email's up there on the screen. If you email me, I'll send you a PDF of the presentation, not a problem. We will send out a link. I have recorded this, so we'll send out a link. What we'll do is we'll take the recording. We have to process it through GoToWebinar, and then we'll send you a link, and you better watch this back again. So that should be hopeful as well, I hope. Good, that's the main questions answered. So listen, thank you very much for your time, everybody. I'm really excited about BIM. I hope that's come across. I hope you've seen something of interest. I hope you feel a little bit more confident, a little bit knowledgeable talking about BIM and the process. Please feel free to get back to us to ask any more questions. If you'd like to know any more, you can email me directly. And thank you very much for your time.